Hydrogen makes 1 covalent bond, carbon makes 4 covalent bonds, oxygen makes 2. All right. Let's talk about nitrogen. We've kind of left that out. Nitrogen is very special. Nitrogen is shifty. It changes. It juggles electrons, just like the thing underneath it on the periodic table. Nitrogen can make 3 covalent bonds. It has 1 happy house of electrons. Like nitrogen gas, those 3 lines mean there's triple bonding. Each nitrogen is making 3 covalent bonds with another nitrogen. So there's my nitrogen molecule. Nitrogen is a very unique element. We're going to talk about that. Nitrogen gas is the most common gas in the air at 80%. Please do not send me an email saying it's 79% because 79 plus 21 is equal to 100. All right, all through rounding error left us with 80, but 79 is okay. All right. This is not an accounting class, by the way, as you can tell. All right, so the triple bonds between the 2 nitrogen atoms are very, 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 very strong and very difficult to break apart. And so how do we go from nitrogen gas to amino groups? When I went to school with Fred Flintstone, lightning was the great story because, you know, it's very powerful and exciting and it wakes people up when you talk about lightning. But it's actually the bacteria in the soil that convert nitrogen into usable. Yeah, a little bit of lightning. Oh, they taught you the same wrong thing too, didn't they? Sorry. It's those boring old bacteria growing in the soil, in the roots of legumes and other things that convert nitrogen gas into nitrogen fixation. And so the soil and agricultural science is very important to me in pharmacology as well. Okay? You should take courses in this stuff. You should take courses for fun to learn stuff. Okay? Nitrogen makes 3 bonds, but nitrogen can make a 4th bond. And when that happens, the nitrogen becomes positive. All right? You'll hear tertiary. Tertiary means 3. All right? Tertiary nitrogen is 3 bonds and is usually neutrally charged. 3 bonds means the nitrogen is neutrally charged. And when we make that 4th bond, that's called a quaternary. So the 4th bond on the nitrogen gives us a positive charge. And that's very important. We'll talk about that very soon. All right, so I think we're moving in slow motion. There we go. Nitrogen can make 3 covalent bonds, and when it makes the quaternary bond, then it becomes positively charged. And I will ask you this on the test, because being able to shift something from non-charged to positively charged, that changes its lipid solubility to its water solubility. And we're going to do a lot of that business in pharmacology, or at least they will. All right, so there's my nitrogen atom with the 3 lonely houses of electrons. And so here is an amino group. All right. NH2. R is a variable group. It can be anything. All right. And there's my nitrogen. It's making 3 covalent bonds. And there's that happy group of electrons that don't make the covalent bond except under very certain circumstances. Well, when the nitrogen makes the 3 covalent bonds, these electrons, they'll get greedy and they'll decide that they want to steal a proton. They have a very positive negative energy. They have very negative energy and they want to go steal a proton, and they will. All right, there's a carboxylic acid. Remember I told you anything that dumps a proton into the water is an acid, and so there's my carboxylic acid. So there's the greedy electrons, and what do? They steal a positive charge from something in the form of a proton, and now I have 4 covalent bonds. You can draw that for me. And you can see how the nitrogen, or the nitrogen becomes positively charged because we've moved the proton over. And now we have greedy electrons over here looking to steal the proton back. And that all depends on what's going on with the R group, if they can throw the electrons back and forth. And that is the game of acids and bases. When you go to school, they'll talk about acid-base balances having something to do with breathing and alkalosis and acidosis and kidney compensation and all that. But the truth of the matter is that acid and bases in a biologic system is actually about moving protons from one molecule to another. And when you move a proton, when you move a positive charge in this direction, you've existentially moved negative charges in the opposite direction. And remember, moving electrons is energy. And what this lecture is actually about, which is hard to tell, I know. All right, so we saw how this nitrogen ended up positively charged. There's my nitrogen making 4 covalent bonds. And because it makes 4 covalent bonds, it ends up with an extra proton, leaving it with an extra positive charge. So it's an ion. That's what an ion is. Ion is just something with a positive charge or a negative charge. Here's a hydroxide. It used to be a water molecule, except some greedy pair of electrons stole one of its protons, and now it's negatively charged. Okay. Negatively charged ions are called anions. Positively charged ions are called cations. I don't care if you know this stuff, but other people think you know everything about this, and they write books and board questions and teach all sorts of medical physiology like everyone is some kind of neutron physicist. All right? I did tell you that any substance that releases a hydrogen ion or a proton into the water is an acid. It's that simple. Well, notice this molecule is the opposite of an acid. It can take that proton right back. It wants a proton. All right? It's going to take a proton out of the water, and that's what a base is. It's that simple. Who knew? So here's an acid. Here's my acid component of the water. Here's my base component in the water. And when you mix them together, they neutralize each other. And here we are again with our byproduct of water. All right. Well, let's talk a little bit about chemistry about the R. R just means variable, all right? So R can be anything. R is not rhodonium or rhodesium or rhodonium or anything like that. R just means it's a variable. It can be anything, okay? Or just a hydrogen. It has to be something. So R is a variable group, and this is our amino acid. Here's our amino. We're getting ready to talk about nitrogen. There's the acid. Why did they draw that carbon? Because that carbon's not part of the backbone. That carbon is something called a moiety. It's part of the functional group of the acid, okay? So when we talk about a biologic acid, just like acetic acid, just like vinegar, all right, there is the acid right there, carboxylic acid. So this is the generic structure of the amino acids. The amino, the acid, moiety is a word we're not going to use in this class, but they throw it around in chemistry because it's just fun to say. You can practice saying moiety sometime. And R is the variable group. I will ask you this on the quiz and the test. You'll see. I think I mentioned R just means it's a variable group. Right? Moiety means a functional group of atoms. Okay. There isn't a carbon in the center. Notice, see those bonds right there? 3 covalent bonds being made with a carbon. So there needs to be 4 covalent bonds on the carbon. So that's where that hydrogen comes from. That carbon in the center, it's called an alpha carbon. All right, there's my alpha carbon right here. It's right in the center, and you can go back and look. It's attached to an amino group, a carboxylic acid group, and an R group, the variable group, and it's hydrogen. All right. That's why amino groups have a right-handed, amino acids have a right-handed version and a left-handed version, okay? Because if you change the way they're positioned around the alpha carbon, well, they'll still be identical to each other, just like your hands. Your hands are identical to each other. They're identical to each other, aren't they? Just about, pretty much, all right? Except they're exactly the opposite of each other. Notice things can be identical and exactly the opposite of each other, okay? Don't be confused by language, okay?